Whether you're joining us in person here at Virginia Tech at Blacksburg or whether you're with us on Zoom, welcome to the 2023 Vecellio Distinguished Lecture. I'm David Ford, the Vecellio Construction of Engineering and Management in the VIA Department of Civil and Environmental Engineering here at Virginia Tech. So just a few logistics for those of us in person. This auditorium has one exit in the rear and two on the sides in the front if we need to evacuate. If so, the meeting place will be the corner of Burris Hall. I invite all of you here to join us for a reception after the end of the lecture. We've several people to thank for making this event possible. First and foremost, the Vecellio family for the endowment. Mr. Vecellio is here with us. Let's thank him. There are others who help. For example, Dr. Julie Ross, the Dean of the College of Engineering, Dr. Mark Widdowson, the Department Head of Civil and Environmental Engineering, and Dr. Kleiner, the Director of the Myers-Lawson School of Construction. I also thank Rachel Atwell, our hostess, and the Vecellio scholars and fellows who've put in a lot of effort to make this possible. Speaking of those Vecellio fellows and scholars, one of the things that the endowment does is give us an opportunity to financially support excellent students in the Vecellio Construction Engineering and Management program. It's my privilege to introduce them to you now. Avi Arun is from Chennai, India. He has 18 years of experience in the mechanical, electrical, and plumbing construction industry in the Middle East, including in high-rises, hotels, hospitals, rail, and airports. When he's done here at Virginia Tech, he plans on joining academia as a teaching or research fellow. Sherlock Banks II is from Hampton, Virginia. He's worked with Jacobs, the FHA, and the City of Newport News. He plans on owning an interdisciplinary engineering firm and becoming a United States congressman to support engineering innovation. We ask that Congressman Banks remember his alma mater when he's in office. Charlotte Clyde is from Richmond, Virginia. She's worked with Whiting Turner and plans on specializing in historical renovations in Boston, Massachusetts. This is her with Ernie and Kitty getting ready for Halloween. Sarah Helms is from Fredericksburg, Virginia. She's worked with Whiting Turner and has done some undergraduate research here in the Civil and Environmental Engineering Department. She plans on graduating in December, joining our master's program, and then joining the construction industry on a full-time basis. Daniel Hickman's from Hookman, Pennsylvania. He's worked with consultant land developments, and he's a member of the Corps of Engineers here at Virginia Tech. He will join the United States Army on active duty in May of 2024, and his specific job will be identified next month. He plans on then transferring to the National Guard and moving into the private sector in engineering. Victoria Pritchett is from Ridgeway, Virginia. She's worked with Georgia Pacific and is a member of the Virginia Tech Corps of Engineers. Corps of Cadets. She will be joining the United States Army as an ordnance officer. And Ben Woolley is from Ashburn, Virginia, who's worked with Creative Engineering Systems, is a member of the Corps of Cadets. He will become a second lieutenant in active duty for the United States Air Force and will then start undergraduate pilot training. Let's please thank and acknowledge these fellows and scholars. The Vecellio Distinguished Lecture provides Virginia Tech and the wider construction industry an opportunity to learn from a distinguished leader in the construction industry. I'm confident that you will come away from this lecture today inspired to excellence. Construction students, researchers, and practitioners. In order to be or become a leader in the construction industry, you need to know and understand about construction operations and project management and concrete and steel and timber and staging areas and critical those are all necessary, but they are not sufficient. In addition, you need to know and understand how to take that knowledge and those tools and those methods and turn those into reliable, useful recommendations and actions to move projects forward. That too is necessary, but not sufficient. If you want to be a true leader in the construction industry, you must also innovate. You must work to do things that will move the industry forward. You must take and develop new ideas and methods and products that will improve the construction industry beyond where it is to make the world a better place. Ut prosim, that I may serve. How do you do that? How can you take underutilized concepts and ideas that may have been around for a long time and turn those into organizations and processes and materials and applications and transform them into things that make a significant improvement on current practices? What are the challenges that you face in doing that, and how can you overcome those challenges? We're going to learn about that today, because our distinguished lecturer today is making that vision a reality. Vaughan Buckley is the founder and CEO of Volumetric Building Companies. They are working to meet the unmet needs of everyone to have accessible, affordable housing. They are doing that by disrupting the housing industry in the United States and elsewhere. They are doing that by building high-density, multifamily housing to rapidly increase the supply in urban areas. They are doing that by enabling developers, agencies, nonprofits to build efficiently and cost-effectively, and by vertically integrating the construction process from concept to occupancy, using technology-enabled design and engineering, precision-driven manufacturing capabilities, and project-proven construction expertise. What this does is it puts volumetric building companies right in the middle of Construction 4.0. Construction 4.0 is the part of Industry 4.0, which is putting high and new technologies into construction projects to have them perform better. As it says on the VBC webpage, we're building the future and improving lives. Volumetric Building Company, also has a Hokie connection through its support of Virginia Tech's Orange County Sustainability Decathlon team, in which 18 Hokies designed an affordable 1,400 square foot zero-energy home in California. It's our plan to continue and develop our collaboration with volumetric building companies. Our speaker, Vaughan Buckley, grew up in a small town south of Sydney, Australia, called Moss Vale. He graduated from Southern Cross University, received a Bachelor of Business in Hotel and Risk Management. He earned his MBA from Arcadia University and his Juris Doctor from Temple in Philadelphia. In 2009, he formed Volumetric Building Companies, where he has led the construction of over $2 billion in modular manufactured or assembled projects. Under his guidance, the firm has expanded in the United States and overseas, making Volumetric Building Companies one of the largest vertically integrated technology construction companies in the world. In April, Vaughan received the Regional EY Entrepreneur of the Year Award, which makes him eligible for consideration for the national award, which will be announced next month. He is actively involved in the Modular Building Institute, the National Association of Home Builders, and the Philadelphia Building Industry Association. Ladies and gentlemen, please join me in welcoming the 2023 Vecellio Distinguished Lecturer, Mr. Vaughan Buckley.
Thank you very much. Too kind. Thank you. Thank you, everybody. You're too kind, Professor Ford, and I appreciate your support. I can't say that I've ever been referred to as distinguished so many times in one introduction, and I'm very grateful for it. Mr. Vecellio, thank you so much for your support of this incredible endowment for the team members that are here today that I am sure will change the world one day with their support and efforts as well. Team, I have a few things to share with you today. And I think I would like to start a little bit with who we are. Not because I think that's overly important for you to know, but it will give you some knowledge as to where my history and background is coming from in the context of what I am saying. So I think it is important to share a little bit about VBC. Professor Ford has done a good job of doing the overall introduction of the firm, so I'm going to skip through this slide with the pretty picture and get to more of what we do on a daily basis, which is combine disciplines that are traditionally operated, provided, sold, and serviced separately. Land development, architecture and engineering, manufacturing, in our case, modules, and on-site construction. These are typically services that developers, owners, builders, and agencies will provide and procure through a bid and tender process of varying levels of complexity on an independent basis. We believe those gaps in the independent procurement are a large part of the challenges that the industry faces today in efficiency, and are also one of the reasons why new technologies such as modular construction are still nascent within the space. When we think about how we view this, it's essentially to change construction from a service to a product. We don't want our clients having to produce independent services and add them together to make something. We want to give them something. And we do that by combining each of those independent services and giving them a building. And we do that in a global footprint. Today, we have offices around the world. We are located in Europe and the US. We have factories on the East and West Coast and in Poland. That gives us the unique opportunity to service parts of Europe, the UK, Ireland, the Middle East, and North America. We get to see the trends in each of those markets. We get to see the needs of each of those clients, and we get to see the difficulties in construction across the board. You'll be happy to know they're generically difficult everywhere. Our headquarters is in Philadelphia, in Pennsylvania, and that is where the company was founded. We produce a various level of product from high-rise to mid-rise, low-rise, apartment buildings, affordable housing, student housing, hotels, and healthcare. This is across many sectors, and the reason for the variety is the cyclicality of this industry, construction itself, as well as the asset classes, which are driven in each of the markets by various funding sources. Today, for example, multifamily housing is lacking funding. You'll find in most urban areas over the next year, we predict and have seen a significant drop in design and entitlement of multifamily buildings that is likely to result in a continued pressure on the housing market in those areas. So what do we do to help? Well, we try and make things more efficient. We build buildings more like you see here in the hospitality space by providing a product to our clients. But does that solve the problem on its own? Unfortunately, the answer is no. We have to also be more efficient in how we do it, and we have to help our clients get a better end product than they would have had if they tried to do it another way. In our case, that's in a factory. For those of you that aren't familiar with modules that we build, if we were to produce a hotel, for example, and you bought hotel rooms from us, you would get the whole room. There would be a television, a bed, the furniture, and all of the fixtures and fittings inside it. It's a concentration of the labor that goes into that product, which can be more efficient in a factory environment. Here is a short video to share with you a little bit about what this looks like. This facility is 14 acres under roof. It's located in Tracy, California, just outside of San Francisco. For those of you that follow the industry, you may be familiar with the former owners of this facility, which was Katerra. We purchased their assets and now operate this factory today. We produce the components that make up the modules, which you can think of as a 3D element, an entire structure or component thereof, by making the floors, walls, and ceilings independently. They feed down an automated manufacturing or assembly line, and work is applied to that product as it goes, with varying levels of human interaction and robotic support. Our intent for machines is essentially to make the lives of the construction workers that are in our factories easier, to reduce the amount of errors that go into typical coordination and clash detection, and to increase the quality of life safety within the building itself. It is not to take away construction jobs. And I think when we talk about that next over the next few comments and macro conditions that the industry is facing today, I think we'll see that's one of our biggest challenges within the space. So as you see here, everything is being installed within the modules in the factory production line, and by the time it comes off at the end, it's a completed building component, which might include a hotel room, a hospital ward, or multifamily housing, depending on which product market we're building. Now, so let's get off VBC and talk a little bit more about construction and why I'm here today. Here is some really depressing statistics for you. This is the construction industry today. And what we start this slide off by saying is that the construction value chain as we know it is breaking. Some people say that it is broken, but you are all engineers and you know that when a chain is broken, it can't get any worse than that, and we're here to say it can. Unfortunately, the statistics that you see on this slide make up a rather depressing set of facts for the reality of the world that we live in today. The amount of value that we apply to a product for every hour of labor that we use is declining. The amount of people that we have to provide those hours is declining. The amount of effort and energy that it takes to build a building is increasing. And the amount of housing that we need to house the very people who build those buildings and support the rest of our infrastructure is increasing. So each of these statistics is going in the wrong direction. The worst one on the page is in the top right. And this is the one that I need your help and innovation to solve, which is that we're losing 4 out of 10 of our most experienced construction workers within the next 8 years. We're talking about work product today that is at the lowest quality, the highest cost, and the highest amount of time it's ever taken to build housing. And we're about to lose 40% of the people that do it. This is a problem. This is a problem beyond the structure and math that goes to the amount of people we're talking about and goes to the very core of what we do. How we design buildings, how we produce buildings is going to make the difference in whether or not we are able to produce enough buildings to house the people that need to live in them, work in them, and provide services to those that require them in every city that we have today. These statistics are not specific to the US. They're particularly depressing here, but they're almost as depressing in most other countries as well. Europe has advanced industrialization, what we do, manufacturing, in ways that the US hasn't, and they're further ahead on the curve. But that alone will not fix the challenges that we have today. For some slightly more depression before we get into the good stuff, let's talk about carbon. Construction really sucks at this. We are the largest provider of carbon to the world's environment today when you consider us across the life cycle chain of buildings, between the embodied carbon that goes into the materials that we use to produce things and the things that you and your protégés will design to make them, through to the way that we actually build them. And the end result there is that we are essentially responsible for the vast majority of all of the emissions worldwide. And when you add that to the industry and transportation that's required to get it there, it doesn't really get any better. So what are we going to do about it? I think ultimately there are many things that we will discuss during this lecture, but the basic situation here is that as engineers and designers of the world's future structures, infrastructure, and buildings, you will have both the responsibility and the opportunity to enhance the way that we live as a planet by making the buildings that we produce better. Whether that means using the materials that you have available to you today, creating new materials, or breaking the mold, you can each do your part with some component of those pieces, but we must do something, and we must do it quickly, because we have two paths ahead of us. One path is innovation. When you innovate, you add value to the product that you produce, you create efficiency in the way that the world builds, and you add knowledge to the folks that are around you. And this can come in many different ways. It could be working on the sciences that determine the methodologies for construction. It could be creating new materials. It could be using materials for purposes other than they were originally designed for, that ultimately enhance the way we build things. That's one path. That's the path today that we need to follow, and the path that we're not entirely on. The second path is regulation. Regulation is the alternative to innovation. It is the last-ditch effort for the politicians of the world to decide that you're not doing good enough and they know better. Unfortunately, they don't. And so when you add regulation, while you may have a goal for a particularly honorable target, you usually don't just meet that target. You add cost. You add waste. And you provide an opportunity for people that are trying to avoid all that extra cost and all that extra waste to take shortcuts because your legislation didn't provide for the loopholes that people will inevitably create to avoid it. So ultimately, that path doesn't add value. Where does innovation come from? It comes from you. We talked earlier with a group of the Vecellio fellows and scholars. Their question was, where does this change come from? And the answer was quite simple. You guys have to do it. You have an opportunity here over the next 30 years of your career and more to make change on the right side of the road. The folks that are in the industry today that have built the products that we use do not have the incentive, the time, or the need. This problem will be yours, and yours alone. There are people here today in the industry and in academia that will help you on that journey and that have more knowledge and experience than you could ever hope to gain. But within the coming decades, they will be gone and you will be left to carry the torch. And so that is why it's so important that today we take advantage of all of that knowledge and opportunity that exists within the industry to make change. And there's a few things that I think the industry is really battling with that it would be helpful for you guys to know about. This is a short list of the things that we're going to discuss, and I'll try and leave plenty of time at the end for us to chat about question and answers as well. The first is interest rates. Most of you haven't had the opportunity to own a home in an interest rate environment that looks like it does today. And because of the interest rate environment that we have today, most of you don't have the opportunity to own a home now either. This market brings with it a few different things that are worth us discussing, and here I'm going to overlay for you how housing is impacted by interest rates. Housing is one part of what you do or will do as civil and mechanical engineers and the supporting infrastructure that's around it, but housing is what drives so many other parts of the construction industry. The interest rate spike that we are seeing today is likely to reduce housing in both multi and single family areas, and the demand is dropping fast. It's dropping in areas that we don't see yet. When we look at multifamily starts, we don't see the damage that's already been done by the interest rate rises over the past year, but when we look at design starts, we see it coming. We recognize that less people are designing buildings, which means less people will be building them. Ultimately, costs are going up and availability is coming down. This is where you start to talk about the opportunity of what that means. And this is where I want to chat with you guys about what innovation can do and where your impact in this market is the best. How many of you have heard of the term you buy at 6 and you sell at 12? Essentially, you're looking at a clock face, you want to buy at the bottom and you want to sell at the top, right? The good news for you is we're close to the bottom. Now is the right time to buy. Now is the right time for you to invest in change, because as this market shifts over the coming years, new technologies and new opportunities will advance at a speed never before seen, because the people that are buying won't have a choice. This is your opportunity to gain that knowledge and expand it now so that you're ready. When a market dips, this is what you get to see. This is an example of a pipeline of products coming into a business, in this case, our business, over the last 6 months. And what's particularly interesting is that you're seeing people are buying. You know, if we're talking about this as a stage of pipeline, at the end of the day, people are moving to contract pretty quickly. There's also a ton of people coming into the business saying, I want to buy buildings. How can I do that? That's all great news. But the real story's in the middle, which is where people aren't making decisions. And the reason they're not making decisions, the reason they're unable to negotiate a contract and complete a deal, is because the macro conditions in the market today aren't allowing that. The interest rates combined with the construction costs are not allowing them to move forward. Those conditions can only last so long. It's basic supply and demand. There will be a cost reduction in labor. Materials will decrease in price, but ultimately the way that we build, the sequence that we do it in, is too expensive. And we will never, at our current pace, be able to fill what we would call the missing middle, the housing that is not subsidized, is not low income, and is not luxury. If you look at all of the cities around the world, and hell, you can look right here in Blacksburg, you'll probably see that the housing that's being built is luxury. That commentary often is told that that's because developers only want to build luxury housing because they make the most money. That is true. But that most money is also actually very small. General contractors that are producing that building are working on single-digit margins, and developers are often doing the same. The reason they're choosing that housing is because it costs so much to build today that they can't actually build the middle housing that everybody needs and make any money. So we need to do better as designers, as engineers, as people that are coming up with ways to build, sequence, and construct. We have to give them an option. And then you get to see, wow, what would happen if I made it easier in this middle stage for people by having a product that was more efficient, more cost-effective? How fast could they move through the pipeline? And the answer there is that the opportunity is phenomenal. Now I want to talk about labor force participation and what we can do here. Another big part of the industry challenge today. If you look at the Department of Labor census statistics, they suggest that we have about a 90-10 split today, that approximately 10% of the construction industry is represented by females. I have a quick story to tell you about how those labor statistics are actually working today, which is that I have a gentleman in our finance department who went to the post office with one of our interns on a very hot day last year. And he was in the post office line, and there was a gentleman that had just come off a landscaping site. Very hot, very sweaty. It was 105 degrees out. He was just grateful to be inside in the air conditioning. And my finance department rep says to him, "Oh, are you in construction?" He said, "Yeah, in construction, super hot out, really rough day." And our controller said, "I know what you mean. I do construction too." This is a guy that spends his time in the office, in the air conditioning, supporting this. And the intern that had just joined us, she turned to him and said, "You're in the office all day. What are you talking about?" Unfortunately, that statistic, "I do construction," coming from my controller to one of these gentlemen in the office, is the same statistic that the Department of Labor is sharing with us today. That 10%, 80% of it is in the office. They're not in the field. We actually have a 2% participation rate for females in the construction industry. This isn't just a fairness problem, which it is. It isn't just an inclusion problem, which it is. It's an innovation problem. We do not have the right level of expertise and environmental experience in the field because the people that are out there all think the same. But ultimately, this is a math problem. Not only do we not have enough people in the construction industry? But the people that serve the construction industry today, the 98% of people that serve the construction industry today are not working in it anymore. Why? Well, they're not working. This is the Department of Labor's census statistics on those who are actually participating in the workforce. And what you'll find is that when construction was at its peak efficiency for the last 100 years, which, by the way, was still the 29th out of 29 industries that are tracked for productivity, we had a workforce participation of males that was almost 25% higher than it is today in the age categories that are entering the construction industry. What does this mean? It means that females are not just going to rescue construction, they're actually rescuing basically our entire workforce, because the participation rates that we have are completely unacceptable across the industry from a workforce perspective. But when you think about construction as a single industry, we're 98% in the wrong column. The opportunity for female participation in construction is massive. The need is even higher. But there are things that we must do as an industry to encourage that participation. It starts with some of the things that you saw in the video earlier. It starts with removing the constraints that are preventing folks from being on site and taking female or male out of it. We can talk about things like building materials that are designed for people to move. Look at drywall. It's a 4x8 sheet. It's designed for 2 people, one on each end, to hold it and maneuver it up stairwells. When you start talking about physical characteristics of the people that need to do that, you are guiding yourselves towards a male workforce participation. So even the building materials we use are sexist. And so the crazy part of this situation is that when we think about what we need to do as an industry to solve this issue, the basics that we need to do are already there, and many industries are already doing them. Construction is an easy one to follow. The environment needs to be safe, and that doesn't necessarily mean safe for females, safe for males. It just means safe in general, right? We need to stop falling off of buildings. This is one of the biggest things that are killing people across the country in workforce is construction is unsafe at heights. How can we fix that? We could put it in a factory, we could build it at ground level, and we could assemble it at heights. That's one way. We have to make the work environment inviting. That would suggest perhaps not having rain inside, right? You go on a job site, it's very cold, it's very wet, lots of snow. In a factory, you don't have that. Ensure your workforce lifestyle is met, that they go to the same place every day, that they're not traveling across the country looking for work, which is something that many people in construction have to do. Factories help fix that. Make the work accessible. We have people in our factories that are in wheelchairs doing electrical work. That's not something you can do in a 5-story building on a job site without an elevator. Make the work fun. Add robots to stuff, it gets more fun. We have lots of opportunity within factory environments to do things that make work more exciting than it is today. And just things about building materials and trying new stuff is fun. But it's also meaningful when you can change the way that others are building as well. So the end results of doing stuff like that are pretty simple. Industrialized construction today, and these might be our statistics, but let's take it more as an industry statement. We can reduce waste, building materials waste, by 50% because we can optimize the flow of the material that's coming in. We're not cutting a piece of lumber on the 5th floor of a building and throwing it in a dumpster, or cutting that out of a computerized algorithm that determines that piece can be used for blocking somewhere else later and saves it. We can make buildings 20% more energy efficient. We can reduce carbon in a building by 66% today over the life cycle of a building, just with our existing technology, no changes. Building with the same materials you build on site, but doing it in a factory to a tighter, more appropriate and efficient building envelope. And we do that with 10x female participation. Today, 1 out of every 5 people that's in our production line is female. Our goal, obviously, is to make us demographically equal. We should be much closer to 50%. But it is amazing the difference in productivity and innovation that you have when you can bring people in that think differently than the folks that have traditionally done these construction activities. Next, I'm going to chat with you about digital flow. This is one of the things that from an engineering perspective makes such a huge difference. This is how we design today. Architects create intent. Engineers typically make that intent a reality, and that reality is then transferred to the general contractors, who will either ask more questions in order to build it or throw some of it away and do it the way they know how to do it because it's easier for them. This is the reality of the situation when it comes to some components of engineering. I say that not to suggest that all of our work is being thrown away as engineers, but just to say that there is information that does not get back to you after you make that design, and general contractors or trade contractors on site have to make adjustments. They don't pick up the phone and call you and say, hey, that line weight that you used confused one of the guys and they built the stairs backwards. They just rip the stairs out and build them again. And that same line weight stays on your drawings for 20 years before you ever go to a happy hour and someone says, are you the person that draws those lines on? You know, I get really confused by how the stairs came out as a result of that. This type of feedback doesn't exist very well in our industry today. So if there's anything I could encourage you to do, it is participate on the job sites and see the influence that good drawings and good interpretation of those drawings can do for the quality and efficiency of the industry. The world's changing a little bit. We're going away from this whole representation, intent, recycle, and we're moving towards a 3D modeled BIM environment. However, that is an inconsistent transit right now. Not everybody is building and working off that same model. Oftentimes, we find that architects and engineers are building their own BIM model. So you have a 3D collaborative model that you can all work on, but you have 4 people building different ones that they don't share with each other. Doesn't really help. So as technologically savvy as each of you will be in comparison to some of the folks that had to implement this technology in the firms that they've gone to, that's another one that I would give to you, is this collaboration is really, really key. Using the license from last year's AutoCAD that didn't allow you to share is not a reasonable excuse for being unable to collaborate. The investment here is necessary in the model and the data. That doesn't mean we have to model everything. Some things are needed, some things are not. How those components interact and how much we spend to figure out how they interact is an equation that we can take. My point in this is simply, while BIM modeling is the future, doesn't necessarily mean that we have to use it for every single detail. And here's an example of a company that tried to do this. They spent $100 million combining these systems together to try and get them to industrialize construction in an automated way and use robots to provide the output. The company that spent this money and connected these systems not just spent $100 million, they actually burned $2.4 billion while they attempted to implement it on the construction side. My point there is simple. Change is hard, and it costs a lot of money. And we can all have great ideas and move things in the right direction, but sometimes it's the simple things that win. Productivity is often more important than ingenuity. Bringing together systems in a way that they work together, and by that I mean literally work, that the end result is something you can use, is critical. This was our investment with the same software. We spent $600,000, and we've now produced 5 times more modules than the company that spent $2.5 billion. This is not because we're that much better than them. It's because we didn't have $2.5 billion. So I encourage you as well, if you get access to the resources to spend, don't just spend them because you have access. There's always ways to do things another way. And for us, this is the combination of those services we talked about earlier to create a product. For you, this could be combining disciplines and trades that are ordinarily procured separately to provide a product for a client that can be replicated in buildings in kits of parts. Basically, every building that we produce today looks like another building we've produced today. A very strong exception to that is Virginia Tech's campus. I don't see anything here that looks like anything else. So this example is not for this campus. But if you get outside of this campus and you go to multifamily buildings or you go to hospitals, they all actually have the same basis, the same bones. They're very, very similar on the inside. So if you can work on topics that help you to create small components of that building that can be replicated in many different ways, you will increase the productivity of this industry substantially. Right now, we custom design almost everything for every building, even though they operate damn near identically. So what does that mean for us? Here's a way that we look at DFMA. DFMA, many of you may have heard of it already. We're talking about design for manufacturing and assembly. DFMA is a relatively simple concept that is used in many industries to essentially ensure high productivity. And the way that you do it is pretty simple. You design, and you look at manufacturing and assembly. The challenge is, people don't necessarily want to buy something that you can manufacture and assemble. There are plenty of things that I could put on a production line, manufacture and assemble efficiently, get it to the other end, and have people go, that's cool, I'm glad it was really efficient, but I don't like it. So we've found that you have to not just build a product, which is something that's designed for manufacturing and assembly. You have to build a system. You have to build something that works, something that people want. And to do that, you need more. In this case, you need the market, and you need to know that it's maintained well. What does that mean? It means that we need to know people want to buy it, and that after they buy it, it doesn't break. That's the basics. DFMA needs to extend to both of those, and I'll give you a quick example of how that works. Here's some of our product. These are all private label products that we have produced so that we can sell our customers the same thing. Why? You might say, well, because you want to make margin on flooring or countertops. And we don't. We really don't mind who produces what. All we need to know is that we can manufacture it the same way every time, and we're not relearning how flooring works or buying a new installation system every day. So we want our clients to choose from our selection because our team knows how to use it. This is the same thing when you're thinking about manufacturing, when you're thinking about mechanical or civil engineering. The components that go into the units that you're building, if they're the same for every customer that you're producing, it gets easier. It's amazing the learning curve every time you try a new system. Innovation doesn't mean changing every time that you make a new design. And so how does that replicate into a building for us? Well, in this example, we have approximately 400 units. There's 20 different types of units in that building. We only have 6 different kitchens. And so I'm able to have our team utilize those kitchens in every module and apartment type, even though they may not be the same as one or the other. That's a way that you can increase the ability for a project to have efficiency. You can do the same thing on site. It doesn't have to be in a factory. But think about that. If I'm designing an MEP system for one particular type of room, but it works for another, why change it? These are some things that make housing more accessible. For example, here, by making some small changes to a cabinet hinge, we can make every kitchen in the building accessible so that if somebody with a wheelchair was to move into our buildings, we're not trying to convert an apartment. We're simply adjusting the existing fixtures and fittings that are in there. This is a small spend. Might add $50 to the project across every unit. But we can offset that by doing other things that make sense for the customer. Like in this case, in this apartment, the amount of time, effort, and energy that maintenance teams spend in student housing buildings turning on breakers that have switched off, not for any of you guys, because you all understand mechanical and electrical engineering to some extent, you know how to flip a breaker, you would be amazed. Student dorm rooms, the amount of maintenance time that it costs for universities to have maintenance teams come into occupied apartments to turn breakers on is incredible. So we moved it and said, let's put it in the hallway. It's a little untraditional. But if we put it in the hallway and put a lock on it that the tenant has access to if they want to flip their own breaker, but the maintenance team doesn't need to get into your unit while you're occupied if they aren't there. That was a $750 savings for this university per unit, which more than paid for their ability to increase every unit to accessible. Now they get to have better access and equity across their portfolio. These are the kinds of trade-offs that you can make as an engineer. And here is an example of product. These are 2 bathrooms that a typical apartment might have. The one on the left, pretty basic. The one on the right, maybe a little nicer. We're going to specifically focus on the mirror. The mirror on the left, if you went to Home Depot and you bought it, is about $60. The mirror on the right, if you went to Amazon and bought that, is about $500. The mirror on the right has a heated back pad so that when the shower's on, it doesn't fog up. It's got a makeup light. It's a nice mirror. But if you apply the principles of DFMA to this situation, we can actually get to a total installed cost of $160 for the mirror on the left and only $90 for the mirror on the right. And that might just seem like magic voodoo math that doesn't make any sense. But when we think about DFMA, I'll itemize it for you. The mirror itself, again, Home Depot or Amazon, there's your price. You want to buy 1,000 of them from Home Depot? They'll sell you that $60 mirror for about $50. You want to buy 1,000 of the mirrors on the right and have a private label version manufactured for you in a facility that produces nothing but those types of mirrors, you can now get that price down to near nothing. You add to that the labor and time that it takes every time you have a different sized, cheap mirror to install, and that you have to move where the studs are, or that you have to move your clips. You have to add blocking because they don't fit exactly the way your wall was designed. And you need to add a light above it because it doesn't have a light, it's just a mirror. And you compare that to your new custom mirror, which you've designed to fit on all of the studs in exactly the way that your walls are always built. You've designed to hang on clips that your team knows how to install, and you've eliminated all of the blocking that goes with it. All of a sudden, that mirror on the right became a lot cheaper to install and a lot cheaper to maintain. And the end result is you end up with a $90 mirror instead of $160, and the mirror becomes cheaper. The better option becomes lower cost. That is really the point of this exercise to share with you, is that the cheapest option is rarely the cheapest option. And the total installed cost, and in some cases total installed value, is really the critical number for you to think about as an engineer. There will be times where you will be dealing with a client and they say, that system is way too expensive. I need you to value engineer it. Hopefully value engineering is one of the words that you will hate the most as you leave and go into private practice. Value engineering doesn't mean value engineering. Value engineering is a fancy word for cost cutting. And in reality, for us to engineer value into a product, we have to change the way we design the product, and that starts with you. So what does that mean for the industry today? Well, it means once we add cost, complexity, and the impact that you can have as designers, we start to think about the value of time. This is an example specific to modular construction, but I'd like you to think of it as a more generic example for you when you're talking to clients about how long does the design I provided, take you to build. This is how long it takes to build a multifamily building on average today. It's around 21 months. It's pretty consistent each month in how it's produced. Rough percentages are averaged month over month, and that's the amount of cash that it takes. A modular building takes about half the time, but it moves the cash a lot quicker. So when you're first looking at something like this, and you'll experience the same things when you're providing an expensive option to a client, is, hey, it might provide other benefits than just the cost. It's much quicker. They say, well, it might be much quicker, but I don't want to spend that money. I don't need that money gone that quickly. And you can encourage them that how long you hold on to the money is not as important as how long you're not holding on to the money. How long is the money out of your pocket for before you get it back is often more important than how many of the dollars you removed in the first place. So on the modular example here, not only are we able to give the cash back on month 10, but they actually start generating rent for the rest of the time that's there. So when you actually overlay them together and think about what's your net cash usage once you get your money back, it's lower. And then you think, well, how long does it take if it goes over a traditional project cycle? Well, it's much longer. You measure them into actual time, and what you end up finding is that the amount of capital that you utilize is reduced if you can use it more efficiently, and efficiently doesn't necessarily mean over a longer period. It means that it comes back to you quicker. So that's an example that I hope that you can utilize in many areas other than just what we do here today. So I have a lot of other stuff that I can share, but I wanted to give you a high-level overview of what we do, how we do it, and how we think about the world, and then give an opportunity for you guys to ask me some questions, and I'm happy to share anything else that we might have here today. So thank you for your time. And what can I do for you? Is there anything that I can answer for you today? you. Yes, sir.
One question I had, kind of with your video, I remember you made a comment about like how you introduce a lot of these machines to make work more efficient and safer, while not sacrificing the amount of potential jobs that can come about with that. So how, like, you get more detail about that? Like, how does that work?
Yeah, I can.
Repeat the question.
Yeah, so the question for those on Zoom and that may not have heard that is, how can I make the statement that we're not eliminating jobs when we're adding machinery to factories? Really, that's what we're getting at, right? If we're adding robots and machinery, how are you not taking jobs away? And the answer to that question is that the jobs wouldn't exist without the robots, right? In this case, these are people that are entering the construction industry that otherwise wouldn't have and are now able to produce more buildings in a different market area than the building is going to, something that is otherwise not possible in construction. An example of this I would give you is, let's say you've got a very robust construction market in a state next to yours. Let's say West Virginia has the opportunity to build housing for, say, DC and Virginia. They can't do it. They can't get the people there. That state will never get the construction money, the GDP support that would come with working on construction activities in another state, because that's not how construction works. Now it can be. Now you can produce a factory where people are gaining jobs in an area that they could never have had them before, to produce construction products for markets that they're not in. That's one way that it's enhancing jobs. The second, which I'll clarify, is my intent in that statement is that the intent of the machines is not to remove jobs. Obviously, if we had someone hammering that nail in instead of the robot doing it, that would be an extra job that would be created for that. But the expectation here is that by augmenting what they do with those machineries, you're now able to produce more housing at a lower cost, which ultimately adds jobs, because the business would never have been able to win those jobs without the efficiency that comes with those machines. And every robot needs at least 2 or 3 people behind it, programming it and supporting it. And the work that we're transferring from and to is very different. So you think about the folks that would have to otherwise swing a hammer or a nail may not be interested in doing that. They might be very interested in programming a machine to do it. So we're opening up the accessibility to others, and I think that's going to be a critical part, not just for us, but for the whole industry to figure out, is how do we open the accessibility to others. Thank you. Yes, sir.
I mean, isn't it the reality is you would probably be doing a service to have that require less jobs in lieu of the fact that we're losing 40% of our construction workforce in the coming years, correct?
Yeah, when you look at the stats, I mean, ultimately we have to do more with less, right? We can't possibly produce the amount of housing we produce today with the same workforce we have today. What will the skills be of future construction workers? Candidly, I'd be actually really, really happy if the skills of future construction workers were very similar to the skills of construction workers today. The reality of the situation is that the folks that have the skill today, that are aging out of the industry, most of our senior supervisors in our facilities are in their 60s. Those folks are the ones that have 30, 40 years experience in that trade, and they can't simply hand it over. You know, I think about Harry Potter and the scene with the pensive, right? You just want to like pull the thoughts out of your brain and give it to someone else. If we could do that, everything would be great. Unfortunately, it doesn't work that way, and we don't have 30 years for the people that they're training to get the same knowledge that they have today. So what will the future skills look like? I think they have to be different. They have to be more diverse. And we have to change the way that we're building things, because we simply do not have the skill left in the industry from a predictive manner. In 8 years, we will not have the skill necessary to build. So there's going to be more technology. One of the unfortunate facts that we were chatting about at lunchtime today is that, you know, the investments in the construction industry to change the world today are in software. Software doesn't change the world. Software is not going to build buildings for us. Buildings are not made of bits, they're made of atoms, and people aren't investing in atoms at a serious institutional level today like they need to. That will change. And it will change because we won't have any buildings to put anyone in, so they'll figure it out, right? Money goes where it's needed. That's another reason why I'm encouraging each of you that the career that you're entering is incredibly important to the national security infrastructure of this nation and of every other in the world. So your job not only will be highly valuable, but it is necessary for your fellow citizens to be able to continue to thrive on the planet.
So you introduce a lot of the strength of modular manufacturing, the whole business model. At the same time, do you notice any of the weaknesses of how it operates, and are you trying to address those?
The question was, I've talked a little bit about the strength, and I haven't as much covered the weaknesses of modular construction. There are many. We could have a whole class on that. There are weaknesses in every industry, especially ones that are nascent. Modular has many. One of them is capital. Modular construction is done in factories. It requires massive amounts of capital. General construction is done on job sites and requires very little infrastructure. As long as you're getting paid and your cash flow is coming in on time, you can usually run a job site okay with a few people. Obviously, you need technology, infrastructure, and insurance behind that. I'm not trying to oversimplify, but ultimately, for an industrialized perspective, you might need to spend $100 million on a factory before you can run modules through it. That's a really big weakness for our industry, and it's one of the reasons why it isn't where it needs to be today, because ultimately, we talked about this a few times in the last few days, the issue is procurement. The reason our industry hasn't moved where it is today is the way that people buy buildings hasn't moved today. So until people realize they can't get the building that they want for the money that they're willing to pay, they don't look at new options. They look at us, fine, we're doing great. We've gone 1,000% growth in the last few years. But as an industry, for us to really make significant change, we need to change the way we buy buildings. And that's coming involuntarily, because we won't be able to buy them anymore for the price we want to pay in the next few years. Think of that as like the adoption of the home computer, right? It's the same concept, right? It's like where people are saying, oh, that is a really fancy technology that costs way too much money and I don't want to use today. And then eventually you get to a point where not only are the tasks that it's able to do making your life easier, but they get you what you want. Now all of a sudden everybody adopts. And we're seeing that across many sectors, but I think modular construction is going to experience a pretty similar change here in the coming years. Yes, sir?
So with the projects being low to high-rise, multifamily residential type projects, I didn't see any, robots or machinery that looked like they were best suited for any steel members.
Mm-hmm.
So how are you able to make such high, particularly the high-rise, out of mainly wood components, modular like that?
The high-rise buildings are all built with steel. The question was, we saw the robots, they were wood. The robots are wood. That particular factory is a wood-only factory. So out of our 5 plants, 2 of them build steel, 3 of them build wood. That's a wood factory. The steel factories, from an automation perspective, you don't need as much because you're not really cutting. Steel's generally where all the cold form is just getting rolled out and snipped. So the machines are pretty basic on that front. And then from a welding and cutting perspective, that's primarily done manually. And I hope, this was fun to share with you about the robots, but I don't want you to think that robots are necessary for what we do or for innovation. Like what I'm sharing here are different ways to think about how we're looking at the industry, not that we're going to need robots to be successful. My goal is that we don't need robots to be successful. Yes, sir.
So for the last 15 years, the Fed has kept interest rates historically low. And it looks like going ahead, they might be significantly higher on the cost of capital. Do you think this might be a significant restraint on the construction industry going ahead?
It is today. And by today, I mean, we can see it in the pipeline chart that I showed. We can see it in the design starts that are happening today. I would tell you in every urban market that we do business, and that's London, Dublin, New York, San Francisco, and LA, there isn't a single multifamily new construction apartment deal penciling in any of those markets that will proceed to construction with financing that is not either ultra luxury or affordable with massive subsidies from the government agencies to get it across the line. And the reason for that is exactly your point. The interest rates are at a place where the investors can't get a return on capital. And we've essentially overpaid for buildings over the last 10 years because leverage was so easy to get. It was absorbed by everyone else in the value chain. And now the interest rates are going up. There's nowhere for that money to come from. So I think we're going to see a black spot in new construction development, and especially the missing middle, as far as I can see, without subsidies, has no help for the next few years. It's going to change the construction market substantially. That doesn't mean that we're not going to have massive amounts of work for all of you, though, because the infrastructure bills and everything else that's coming out, the money's just moving different places, right? It's going into highways, hospitals, healthcare. In the UK, it's defense infrastructure. In Ireland, it's healthcare. On the East Coast, it's subsidized affordable housing. On the West Coast, it's homeless housing. The states and federal government are putting money into these things, and we will always be building something. But it's going to be a tough time.
Thank you.
Thank you.
So, don't leave. So, as token of our appreciation for you being here, we have a few things. Can I get help from our scholar or fellow? Thank you very much. I think for the folks online, on Zoom, we're done here. And for the rest of you, thank you very much for joining us. You're certainly welcome to stay for the reception out in the lobby. Thank you.
Thank you much. Wow, there's lots of things.
Lots of deliveries.
Whoa.
They're all free.
Oh my God. Well, thank you so much.
Are you?
Oh wow, look at this.
Christmas.
Thank you.
Yeah.
Thank you very much.
you.
Much
It was nice to
appreciated.
meet you.
It was a pleasure.
Thank you.
Thank you.
Yeah, thank you so much. It was great to hear from you.
Awesome. Awesome.
Great
Look
job.
at this. I've got all the bags. Wonderful. Do I have a hokey stone in there?
Oh,
Not
You're
gonna
telling me he
spoil
doesn't do it.
anything.
He doesn't do it.
He says there's a hokey stone in there.
Oh,
we
is there a
we were
hokey
making jokes last night because he
making
said
jo-
they're
well-
like we don't give any hokey stone away anymore. They're too much
Mike
money.
told him about how rare they all are. So, well, you'll just have to see.
I will.
So,
Oh yeah. You,